So what is short circuit ratio? Generally, short circuit ratio is defined as the ratio of field current. See, field current required to generate rated voltage on open circuit to the field current required to circulate the rated armature current on short circuit. So here you can see that this is nothing but the field current. This is the value of field current which produces rated voltage upon open circuit. Okay, and this is nothing but the field current which produces a rate or it flows a rated current in the armature winding upon short circuit. So what is SCR? SCR is nothing but you can see here it is IF required to generate voltage, rated voltage upon open circuit upon field current required to flow a rated short circuit current in the armature winding. So if we follow this diagram, if we have plotted the open circuit characteristic and short circuit characteristic, you can see here, let us say suppose this is nothing but the field current which is required to produce the open circuit voltage on open rated voltage upon open circuit, and OD is nothing but the field current which is nothing but the field current which circulate rated current upon short circuit in the armature winding. So short circuit ratio is OA upon OD. This OA distance upon OD which is equal to AB upon D. So if we see if there is a triangle which is bisected by parallel line, then this ratio is similar. So we can write down it is AB upon D. Now this XD is nothing but AC upon AB. So what is XD? XD is the reactance, okay, and this is base reactance AC upon D. So what is the necessity of parallel operation of three-phase alternator? That is the point. The first thing, to meet increase in load demand. जसं मी आता सांगितलं की ज्या केसमध्ये लोड डिमांड इन्क्रीज होणार आहे, that increase in load demand we have to fulfill. That's why we have to do the parallel operation. Second thing, continuity and reliability of power supply. That means, see, suppose what happened, I will take the same example. There is a 3 load, okay, and these 3 loads are supplied by only single alternator, okay, and that alternator is having, let us say, capacity of 10 megawatt, but only single alternator it is supplying to these 3 load. But due to some reason, what is happening, these alternators fail to work. What will happen? All the supply will get discontinued, right? But instead of this 10, if I'm going to supply this load with 2 alternator of, let us say, 5 and 5 capacity. This is 5 also, and this one is also 5. So what will happen? Suppose I have to do the I have to carry out this maintenance of this first alternator. So what I will do? I will just reduce some load which is not necessary. ठीक है, जो अर्जन्सीचा लोड आहे, जो इमर्जन्सी लोड आहे, तोच फक्त मी ऑन ठेवेन, and I will supply through this second alternator, and I will carry out the maintenance. Okay, so what will happen? The reliability and continuity of supply will be maintained. So this is the one of the advantage of parallel operation. It may be 5 and 5, or it may be 6 and 4. Okay, so this is second necessity. Third, economic load dispatch. Okay, again the same thing, to supply the load with some low rate feasible prices, this parallel operation is necessary. Then next is a spinning reserve capacity. So it is possible with parallel operation. Then unit commitment and decommitment. This is also one of the advantage and requirement. And finally is a efficient utilization of available units. So which are the conditions which are required for parallel operation of three-phase alternator? First is terminal voltage of incoming machine should be same as busbar voltage. That means, suppose this is alternator, its output voltage is 440. Okay. So this voltage must be equal to the busbar. This is busbar. That is terminal voltage of incoming machine should be same as busbar voltage. Third, second case, phase sequence of incoming machines should be same as busbar. It is similar like this, somewhat like this, and this one is B phase. The second point, that is phase sequence of incoming machine should be same as the busbar That means now third condition, that is frequency of incoming machine should be same as bus bar frequency. So these are the three conditions which are required to fulfill for the parallel operation. The first thing is the terminal voltage of incoming machine should be same as the bus bar voltage. Second, phase sequence of incoming machine should be same as the bus bar. And third, frequency of incoming machines should be same as the bus bar frequency. लक्षात येते की नाही ते? Now, there are different methods to check or to do the synchronization of alternator. So first is a dark lamp method. This is bus bar, A line, B line, C line. Again, this is incoming machine, armature of alternator. It is connected to this bus bar through synchronizing switch, but initially it is open. And parallelly, three lamps are connected, and you can see here, these lamps are connected in between same phase. Means suppose this is lamp 1, so it is connected between C and C of machine. It is connected in between C. This also connected in between, means these lamps are connected in same phase. Okay. So what will happen if three conditions of synchronization occurs or it matches? These lamps will not glow. So if three conditions of parallel operations are matches, these three lamps will not glow, and if such condition will occur at that time, we can connect or close this switch, okay, to operate or to connect this machine to the bus bar. Why it is called as a dark lamp method? Because all the lamps are connected in same phases. Okay, and if three conditions are matches at that time, it will show the proper conditions to do the parallel operation or synchronization of this alternator with bus bar. Okay. Now next method is one dark and two bright method. Okay. So what is happening in this case? Generally, suppose frequency mismatch is there and a little bit voltage difference. असं म्हणूयात की आपण just मशीनचं व्होल्टेज आहे 440 व्होल्ट अँड बसबारचं व्होल्टेज आहे सपोज 420. तर या केसमध्ये काय होतं? वी आर अनेबल टू स्पॉट दॅट ब्राईटनेस. ओके. So we are not getting proper synchronization instant. Okay. So that's why we may prefer one dark and two bright method. So in case of here, one dark and two bright lamp method, lamp EL1 connected between R and R dash. See here, this lamp EL1, it is connected between R and R dash. Second, lamp 2 connected between Y and B dash. Y and B dash. And lamp 3 connected in between B and Y dash. सो या केसमध्ये होणार काय होईल की जर तिन्ही कंडिशन आपल्या फुलफिल झाल्या तर एक लॅम्प हा टोटली डार्क असेल and remaining two lamp it will be brighter. Okay, and if such condition occurs, we can connect that alternator to the bus bar. Third is one dark and two equally bright lamp. Sorry, this is the just its explanation. So these are the conditions at which we can see when fast sequence of lamp glowing in this way, L2, L3, L1. And if such condition occurs, we can synchronize our alternator. Third step or third method is use of synchroscope. If it is moving towards the slower, at that time the synchronization instants occur and we can connect that machine to the bus bar. So these are the three generally methods to do the parallel operation. You may go through it.